I'm Dr. Dominic Hare at the Florey Institute of Neuroscience and Mental Health. I'm a chemist by training, but I work into trying to work out what chemical reactions cause Parkinson's disease. So the idea here is that interdisciplinary science, about bringing a whole bunch of people together to look at how diseases start, how they progress, how they end, trying to find ways to actually target the chemistry of disease to change it. And in science funding, it's often overlooked because it's the very, very basic start of the disease. There's this disconnect between basic research and clinical trials, and it's really important for someone like myself to try and bridge that gap, that we can actually look at basic science as a way that we can develop new treatments that are going to work and will work if we put time and money in.
Excellent. So this ties really well into science communication, because often people think, oh, the populace needs to know about the science, but there are so many academic disciplines of science. There needs to be translational research done to help get past that valley of death, whatever they call it, so that the actual fundamental science can get translated into useful treatment.
Absolutely. Well, so I run a small lab group at the Florey. So I have a PhD in analytical chemistry. The postdocs who work for me, one has a PhD in geochemistry, one has a PhD in nutrition, one has a PhD in neuroscience, and one of my major collaborators has a PhD in botany. And we all work together for the same cause, which is working out how metals, in particular iron, are involved in Parkinson's disease. And it wouldn't be possible without all these different skill sets. I mean, I may run the group, but I know very little about geoscience or nutrition or botany, or to actually work with a cohesive team with all these different skill sets are what we really need. No one person makes a discovery or invents something nowadays. It's always a team. And we need to be able to bring those types of people together in an environment that supports it.
Absolutely. So, in abstract, what's so important about science? I mean, why did it graduate from philosophy? What's so special about science?
Well, science covers everything from understanding why we're here as organisms living on this planet, to how the planet formed to be what it is, what we're doing to the planet, what we do to ourselves, how we can be better people, how we can be a better society. And science is the area I work in is atoms and chemicals and molecules, but it's so much more than that. It's the basic building blocks of life to the fabric of the society we live in. And it is very philosophical still. And I think it's great that a lot of scientists still approach it in a very philosophical manner. But what's really important is finding ways to communicate with the populist movement and people who are I think more questioning of things than they've ever been, is to be able to create convincing arguments that speak to people without what they view as jargon and gobbledygook that to us might make a whole lot of sense, but we spent years and years studying it. So it's really important for scientists not only to be on top of the work they're doing and the latest advances in technology and so forth, but also to know how to communicate that to the everyday person they meet on the street. I mean, ultimately, my research is funded by Australian taxpayers. So I need to be able to tell an Australian taxpayer that their money's being well spent.
Fantastic. Now, in the spirit of updating beliefs based on new evidence and empiricism and the scientific method, what have you changed your mind about that you'd like to share? You can pass.
What have I changed my mind about? I wouldn't necessarily say I have changed my mind about particular areas of science. What I have done is I've learnt new things that I never thought I would. I did a degree in forensic science. I could dust for fingerprints. I now work, 10 years later, I work in one of the world's leading neuroscience institutes, working at the very forefront of why Parkinson's disease happens. Approaching science with an open mind is the most important thing. Perhaps the term hypothesis gets thrown around a little bit too much in science, in that people get tied to they think they know what the result is going to be, and they lean towards that side. And that's something that I think needs to be a culture shift in science, that we're testing a hypothesis. We can't have any presumptions on what's going to happen. So that's why open-mindedness is one of the most important things. I will also say that through science, I actually changed from being an atheist to an agnostic. Mostly because in working in neurodegenerative diseases, I discovered how important faith was to people who are suffering from chronic illnesses, and how important it actually is for their own well-being. And from personal experience, family members with diseases and such, That is probably one of the biggest shifts that I've had. That I think would be some people would think is unexpected for someone working in science, but yeah.
Okay. What are you positive about with regard to the future of science, especially neuroscience?
Well, neuroscience is at the moment far and away the most popular area of science for new researchers coming into. What I'm excited about isn't necessarily the most technologically advanced areas of neuroscience. It's not deep brain stimulation or stem cell therapy. What I'm excited about is this whole idea of collaborative research, working out how we can bring skills from completely unrelated disciplines that are going to impact in neuroscience. It's my interest is repurposing old drugs for new treatments, and I think that the more we understand about why diseases happen, the better chance we have of actually preventing them.
Excellent. Thank you very much for your time.
Very welcome.